Hello friends, hello everyone. I hope you can see this video. I hope you are able to listen me. Let me know guys if I'm audible. Very much good evening. So I welcome all of you guys. Let me know if I'm audible so that we can start with this session. Very nice. So guys, we are going to start with control system, and the topic that I'm going to start with today is a time domain analysis, in which we are going to do a steady state part today. Okay, let's begin with this. So let us consider the system. This is, G of s, R of s. Let's say it is input. Then we have summing point. I'm sure you know this. Let us assume negative feedback system. This is H of s. A typical system I'm drawing, guys. Okay, nothing great. I'm doing nothing great, guys. I'm just drawing a typical diagram of a closed loop control system. Is it? So let me assume, okay, this is what we call as B of s. That is nothing but feedback signal. Let me assume this is E of s, stands for error signal. So I'm sure you know those things. Okay, so C of s stands for what? Output in Laplace domain. Isn't it? Next, R of s, it stands for what? Input in Laplace domain, guys. B of s stands for what? It is nothing but a feedback signal in Laplace domain. And of course, E of s is what we called as error signal, guys. E of s stands for error signal. Am I right? Yes, Vijay. Okay, so for 1 year गेट के लिए क्या करना चाहिए? Okay, start preparing from now only. I hope you have started preparing. Okay. Yes. So we are going to start with steady state error. Okay. Keep watching all live lectures, Vijay. Secondly, you can, okay, Vijay, I guess you are from first year. Then this is not a place for you. Okay. So guys, let's start with steady state error now. Okay, so here I'm going to tell you something about steady state error. Before that, I'm sure you know about this system. Okay, I'm sure you know about this system. Now, this is what we called as a summing point, guys. Okay. And obviously, the job of summing point is to add two inputs. One of them is R of s, guys. The next of it is B of s with negative sign. So what is the output of summing point? Can anybody tell me what is the output of summing point, guys? It is addition of two inputs, R of s along with B of s with negative sign, guys. Can anybody tell me what is E of s then? What is E of s? Yes, those who are watching can definitely tell me what is E of s now. Very simple question I have asked, guys. What is E of s then? Okay, so if you have applied for GATE 2021 exam, and if you get qualified, okay, it just you get qualified. Okay, so you don't get those benefits until and unless you score well. So aim should not be only qualifying the exam, but to gain the maximum marks. Okay, so for that I have already posted a video on Ekeeda channel. What are the benefits after GATE? You can just search opportunities after GATE, okay, on Ekeeda channel. I have already posted a video regarding it, so please watch it. So guys, let's switch back to our topic. E of s, okay, somebody has answered it is R of s plus B of s. Reddy, you are wrong this time. E of s is equal to, it will be R of s minus B of s, guys. R of s minus B of s. Why minus? Because there is a negative sign, guys. Because there is a negative sign. Okay, so yes, irrespective which year you are into, definitely you should think for a 2-year program of GATE, because Right now you can just think to only qualify, but in the next year you can definitely think for scoring the maximum marks. Okay. Hello, Sania. Saina, sorry. So let us begin with this. Let us begin with this. E of s is equal to R of s minus B of s, guys. Now you should understand one thing. You should understand one thing. I'll tell you the basic thing, guys. See, for example, if you have a block like this, okay, this is called as a block input. This is called as a block output. Okay, so this is, let's say input is X. Let's say output is Y. And let us assume the something written into the block, let us say it is H. Then let me tell you, whatever written inside the block is called as a transfer function, guys. It is called as a transfer function. This is obviously called as block input. This is called as a block output. And you should know the transfer function, guys, is always output upon input, guys. So transfer function H is always output upon input, that is Y upon X. Or I can shift X to this side and I can write Y is equal to what? H into X. Moral of the story, output, okay, output what? Y is always equal to input, that is X, multiplied by transfer function, So ये चीज दिमाग में डाल लेना, guys. Okay, input into transfer function, I repeat, input into transfer function is always output. So keeping this in mind, if you look at this, okay, look at this. B of s is over here. This is a block, guys. Okay, input of this block is what? Come on, it is taken from C of s. C of s is what? Input. B of s is what? Output. H of s, obviously it is transfer function, guys. Yes or no? Now try to understand, guys. Output B of s can be written as C of s into H of s, because input into transfer function is output. Yes or no? Yes. So can I rewrite the above expression E of s, guys, as R of s minus, say I'm going to replace B of s as what? C of s into H of s. I hope you got that. I'm sure you got that. Yes or no? If you have not understood, ask me, guys. I'm explaining from basics only. Okay. Okay, great. So let's go ahead, guys. Let's go ahead. I'm writing E of s. I'm writing E of s as it is, equal to R of s as it is, guys, minus. Now look at C of s, guys. Can you see C of s is actually output of this block? Now concentrate on this. This is output, guys. Okay, input of this block is what? Come on, E of s. Transfer function is what? G of s. Again, output is equal to what? Input into transfer function. I repeat, output is equal to input into transfer function. Come on, what is input? E of s. What is transfer function, guys? G of s. So if you multiply these two, this is equal to C of s. So what I'm going to do, I'm going to replace this C of s. I'm going to replace this C of s as, come on, can anybody tell me what you should replace C of s with? Come on, tell me. Is anybody going to tell me what needs to be replaced C of s with? Very nice. Very nice. E of s into G of s, guys. Very nice. E of s into G of s. And by the way, we already had H of s. So let me write it as it is. I hope you understood this. Next, guys, what I'm going to do, I'm going to, shift this to left hand side. I'm going to shift this to left hand side. So I can take actually E of s common. I can take E of s common, because E of s we have here also and here also. So if I take E of s common, what we will have in the bracket? 1 plus G of s into H of s, which is only equal to R of s, which is nothing but this, isn't it? Now what I can write over here is E of s. Finally, I can write E of s formula as R of s whole divided by 1 plus G of s H of s. I hope you understood this. This is nothing but I have derived, error formula. I have derived my error formula in Laplace domain, guys, in Laplace domain. So let me write it. Let me write it. What you have derived, let me write it on the next page. So let me write it. E of s equal to R of s divided by 1 plus G of s into H of s. This is what we have written, guys. This is what we have written so far. Okay. Next, pay attention carefully. What we have understood. Come on. E of s stands for error. In which domain? In Laplace domain, guys. E of s is error in Laplace domain. I hope you understand that. Okay. Next. So try to understand when I'm saying error, guys. When I'm saying error, okay. So what I'm doing, I'm drawing some output with respect to time. I'm drawing some output with respect to time, guys. Okay. So if you remember, this kind of response we got, okay, out of which the response which is steady with respect to time, I'm talking about this response. This is what we call as a reference input. And you know that reference input is also called as ideal output. So this is ideal output. But let me tell you, you don't get ideal output immediately. It takes some time, guys. Therefore, what I've drawn over here is what we called as what? Actual output. This is called as actual output, guys. I hope you understand that. Now, see, you know what? Ideally, it should be steady, but practically, it raises like this. It raises like this, and slowly, it try to become what? A reference input. Yes or no? But at the end, you will find some difference. You will find some difference. And obviously, when I say error, guys, it is nothing but the difference between ideal and actual. Yes or no? When I say error, guys, it is always a difference between ideal and actual. So if you see at t equal to 0, guys, if you see at t equal to 0, can't you see the error is maximum because the difference is maximum? Yes or no? But slowly, if you see, error is reducing, error is reducing, error is reducing. And at a point, as you can see, error has become constant. So here, error is said to be constant, guys. Am I right? Can't I say when error is going on reducing when time is progressing ahead, and therefore I can say that it is error which is function of time. So I can say E of t is a function of time. Okay, is this line justified for you guys? Have you understood why I write E as a function of time? Because as you can see, when the time is processing ahead, when time is progressing ahead, guys, as you can see, the magnitude of error goes on decreasing, and at the end, as you can see, error becomes constant. So can't you see that error is a function of time? Yes or no? Yes. So if you see our topic, guys, we are interested in steady state. We are interested in steady state, guys. So what is meant by steady state? Look at this. I'm interested in this part. If you remember, this response is divided into two parts, guys. Okay, the first part is what we called as a transient part. Am I right? And the remaining part is called as what part? Come on, guys. It is called as a steady state part. Yes or no? So what we are interested in this part this time we are interested in this part. So I have to see, error, which is in steady state. Therefore, it is called as ESS, guys. It is called as what? ESS, guys. ESS stands for a steady state error. ESS stands for steady state error. Now, my question to all of you. You get ESS, that is a steady state error, at the beginning or at the end? Come on, guys. You get ESS error at the beginning or at the end? Can anybody answer me? Very simple, silly question I have asked, guys. Come on, tell me. ESS, that is nothing but a steady state error. Do we get steady state error at the beginning or at the end? Very good, Prasanna. Very good. Is there anybody who wants to differ with Prasanna? Very good. Very good. Gopi, you are also right. We always get error, that is steady state error, at the end, guys. At the end. Now, this word is very, very important. Why this is very important? I'll tell you. Have you heard about something called as a initial and final? Okay, initial and final. So, shall I call this error as a final error or initial error? Can anybody tell me? Shall I call my error as a final error or initial error, guys? Because I'm getting that error at the end. What should I call? As a initial value or final value? Very nice. It is a final value. And I'm sure you'll agree that error is a function of time. Error is a function of time because I could actually see physically error is reducing with respect to time, guys. So you know what? Now I can write, steady state error. Look at this. Very, very important statement I'm making, guys. Steady state error. Steady state error as in what? Come on, guys. ESS. Hey, come on. Can I say actually ESS is nothing but error with respect to time? Okay. Error with respect to time. But you know what? At the end means I should get a final value. I should get a final value, guys. Final value means what? Final value means what? Limit t tends to infinity. Try to understand. Try to understand. Limit t tends to infinity. You shouldn't take literally t value equal to infinity. No, guys. T equal to infinity is used in mathematics to show final value. T tends to 0 is used in mathematics to show you the initial value. And as I asked, ESS is an initial value error or final value error? You said it is a final value error, guys. And that's the reason why I have written limit t tends to infinity E of t. Hey, tell me, guys, have you all understood this? Okay, I want to know from you guys, have you all understood this? Yes, of course, t can tend to 0 also. But then if you substitute t value equal to 0, you will get initial error, and initial error is a maximum error. And we are not interested in maximum error, guys. We are interested in a steady state error. And steady state comes when t tends to infinity, guys. I hope you understood that. Hey, let me know, guys, have you all understood this? It's a very simple logic I said. Why ESS is limit t tends to infinity E of t. Okay, great. So I'll go ahead, guys. Okay. So what I got on the previous page, let me write it again. ESS is actually E of t. Actually E of t when time approaches to infinity, guys. When time approaches to infinity. Okay, let me just write it properly. Just stay tuned, guys. Okay, ESS is what? E of t when time approaches to infinity, guys. Okay, so I'm going ahead, guys. Pay attention. Very, very important. You should know something called as a final value theorem. I repeat, you should know something called as a final value theorem. The reason I'm going for final value theorem, because I'm concerned about final value error. Okay, this is nothing but a final value error. If it would have been, initial value error, I would have gone for initial value theorem, guys. Okay. So, okay, now somebody is saying ESS is equal to E of t into E of S, right, sir? No, just hold on, guys. Just hold on. Final value theorem, guys. Final value theorem. Pay attention, guys. Let us say there is f of t, and the Laplace transform of f of t is what? F of s. Common sense. Yes or no? F of t's Laplace transform is f of s, guys. Now, when I say f of t, and I'm saying, let's say f of t is final value. So in order to show final value in mathematics, we substitute t value as infinity by writing limit t is tending to what? Infinity. T is tending to what? Infinity. This is equivalent to, please try to understand, this is equivalent to, I'm saying equivalent to limit s tends to 0, s into f of s, I hope you understood this. This is called as a final value theorem, guys. This is called as a final value theorem, where you can relate f of t with its Laplace transform f of s. When you substitute t value equal to infinity, guys, you substitute s value equal to 0 and multiply the same f of s with s, complex variable. So this is called as a final value theorem. Now, guys, don't forget that ESS, guys, ESS was nothing but limit t tends to infinity, guys. T tends to infinity E of t. I'm sure you'll agree with that. The same statement I have written over here. Yes or no? Same statement I have written over here. Now this is equivalent to. Okay, now refer, final value theorem, guys. Refer final value theorem. Can't I write? This is equal to, limit s is tending to 0, guys. S into. Now for f of t, if the Laplace transform is f of s, guys, can anybody tell me what is the Laplace transform of E of t? Guys, I'm waiting for you. If f of t's Laplace transform is f of s, what is Laplace transform of E of t? Obviously, it is E of s. Okay. Obviously, it is E of s. Yes or no? And let me tell you, guys, let me just go back to the previous slide and let me show you. Okay. Look at this. We already had, value of E of s, guys. Look at this. We already have the value of E of s. What is that? It is R of s upon 1 plus G of s H of s, guys. Yes or no? Very good. So I'm over here. I'm going to substitute this E of s value. Okay. Finally, what I can write, ESS is equal to, okay. So this side I'm going limit s is tending to 0, guys. S into. Now E of S value, if you remember, it was R of S upon 1 plus G of S into H of S. Okay, I hope you understood this, guys. It's a very simple basic formula. ESS formula is derived, guys. ESS formula is derived now completely. E of S is always equal to, sorry, ESS is always equal to limit S tends to 0, S into R of S whole divided by 1 plus G of S H of S, guys. Okay. So if you look at this relation, guys, I'm sure you must have actually seen this formula. I would say primarily ESS depends on R of S and E of S also depends on G of S, H of S. Okay. So when I say ESS depends on R of S, guys, when ESS depends on R of S, what is R of S, guys? Come on. R of S stands for input. R of S stands for input. Yes or no? And when I say, guys, G of S, H of S, when I say G of S, H of S, guys, okay, of course it is input. Okay. When I say G of S, H of S, guys, then G of S, H of S is nothing but system parameters. Hey, what does that mean? Can I say my E of S is going to change? My ESS is going to change when R of S changes, or G of S, H of S changes. And G of S, H of S are nothing but system parameters, also known as loop gain. Also known as loop gain, guys. Okay. And yes, of course, R of S can be any kind of signal. Yes, R of S can be any kind of signal. Okay. So I would say ESS is a function of input, guys. Function of input. And it is also function of system parameters. And system parameters means, I mean to say, G of S, H of S, and G of S, H of S is of course known as a loop gain. Is of course known as a loop gain, guys. Yeah, I'm sure you understood that. Okay. If you have any doubts, guys, you can definitely ask me. You can definitely ask me. Okay. So since I have understood, boss, that ESS depends on input, I have to see how ESS changes when input changes. Also, I have seen ESS also depends on system parameters. So also I have to see, guys, if system parameter changes, how my ESS is going to change. Let's see, guys. It is going to give you a great insight in the topic. Let's see. So we are going to see dependency of ESS signal on input signal, guys. Okay. So here, what I'm going to do, see, here I'm going to tell you the formula again, where ESS was limit S tends to 0, S into R of S upon 1 plus G of S, H of S. Okay, this is the formula that we have derived, guys. Yes or no? So here ESS, as I said, it depends on input also, and ESS depends on G of S, H of S also. And you know what? This H of S is what we called as a feedback element. I hope you remember that H of S is called as a feedback element. Now let me clear you one thing, guys. Let me clear you one thing. In control system, you are going to learn many formulas. Okay, you are going to learn many formulas, or you're going to analyze many systems, out of which some systems are unity feedback system and some systems are non-unity feedback system. Guys, can anybody tell me, when it is a unity feedback system, which value is known to me? When it is a unity feedback system, guys, which value in this formula is already known to me? Can anybody tell me? Very good. H of S value. And of course, H of S value, when it is equal to 1, it is called as a unity feedback system, guys. And when H of S is, it is not equal to 1, it is other than 1, it is called as a non-unity feedback system. Let me tell you guys very clearly. In control system, there are set of formulas which are applicable only for unity feedback system. And there are a set of formulas which are applicable for unity feedback system also, for non-unity feedback system also. So lecture wise, I'll keep you telling that. You have to always make a note, guys. So at the end, you will have absolutely no confusion on what to do. Pay attention. I said, I'll repeat my statement. Some formulas are applicable only for unity feedback system. Some formulas are applicable for unity feedback system as well as non-unity feedback system. So this is the first formula. Make a note. This is applicable. Okay. Let's create a suspense. I would like to know from you, from your existing knowledge, can you tell me whether this formula is applicable only for unity feedback system or both? Come on, guys. What do you think? This ESS steady state formula, what you have derived, is applicable only for unity feedback system or for both? Okay. Okay. Even Prasanna says both. Okay. Reddy says both. Is there anybody who wants to differ with this? And let me tell you guys, you're right. You're right. Please remember and please make a note. This is applicable. This formula is applicable. I'll tell you definitely wherever it is not applicable. Okay. So it is applicable for unity as well as, come on, non-unity feedback system, guys. I hope you understood this. I hope you understood this, guys. Okay. And let me tell you, hey, what is going to happen if h of s is equal to 1? See, if h of s value equal to 1, this formula will become what? It is ESS equal to limits s tends to 0, s into r of s upon 1 plus g of s only. I hope you understood that. Okay. The only difference that h of s has become 1. That's it, guys. That's is. Okay. So yes, there are many formulas which are applicable only for unity feedback system. But guys, don't worry. This formula is applicable for unity as well as non-unity feedback system. I'm moving with my further discussion, guys, because we whatever R we have, okay, we have to complete with maximum things. I'm going ahead. I'm moving faster, guys, now. Okay. So I'm going to see dependency of ESS in terms of input signal. Okay, in terms of input signal, and those input signals which I'm going to take is a unit step. Then I'm going for unit ramp, and at the end we will see, unit impulse or a unit parabolic. Let me correct, not unit impulse but unit parabolic. So for these three types of input, guys, we are going to see the variation of ESS. We are going to see the variation of ESS, guys. Okay, unit step, unit ramp, unit parabolic. Okay, everybody look up. When I say unit step, guys, when I say unit step, okay, always remember R of t is always equal to 1. R of t is always equal to 1, and therefore R of s is always equal to 1 upon s. I hope you know this. When I say, unit ramp, don't forget, guys, R of t is considered as t. R of t is considered as t, and therefore R of s is always 1 upon s square. Please don't forget that. Please make a note of it. Please make a note of it. Okay. So when I say, unit parabolic, this R of t is always t square by 2. Come on, this is standard formula. Okay. T square by 2. It is called as a unit parabolic, guys, for which R of s, that is nothing but a Laplace transform of t square by 2. If you apply formula, you will get 1 upon s cube, guys. So I hope now you have understood these formulas, guys. Okay, very good. For ramp, it is 1 upon s square, and for parabolic, it is 1 upon s cube. For unit ramp, it is 1 upon s, guys. Please remember the final thing. Okay, final thing. So for unit step, 1 upon s. For unit ramp, 1 upon s square. And for unit parabolic, guys, it is 1 upon s cube. Okay. So let us start with first case, guys. Very quickly. I'm starting with the first case. So first case, guys, I'm going to take a unit step input. I'm going to take a unit step input, guys. And for unit step input, I'm sure you remember R of s is equal to what? 1 upon s, guys. 1 upon s. I'm moving faster, guys. I'm moving faster. Okay, let me know if I'm moving so fast or if you're not understanding. Okay. So ESS that we have derived, guys, what was that? It was limit s tends to 0, s into R of s whole divided by 1 plus g of s, h of s, guys. Yes or no? Next, can't you see R of s value is equal to 1 upon s? Yes or no? R of s is equal to 1 upon s. So let me substitute. What I'm going to get, ES is equal to limit s tends to 0, guys, s into 1 upon s whole divided by 1 plus g of s h of s, guys. Your ss gets cancelled. Am I right? Your ss gets cancelled. See, in the numerator, we have only one. In the numerator, we have only one. I mean to say it is independent of s. Even in the denominator, we have one more one. Again, this is independent of s. Can't you see? This limit s tends to 0 thing is applicable only for g of s, h of s, because only this is a function of s now. Yes or no? So I need to, reframe this ESS equal to 1 upon 1 plus limit s tends to 0, guys, g of s into h of s. I hope you understood this. I hope you understood this. Yes or no? Okay, let me know, guys, if you have not understood this. See, we cannot comment whether we get finite value, zero value, or infinite value. It depends. Okay, so wait for that. Okay, this is what we have ESS, guys. This is what we have ESS. Now I'm getting into something called as a unity feedback system, guys. Look at this. Look at this very carefully. If I'm writing if, okay, if h of s equal to 1, guys, if h of s equal to 1, guys, then this is known as what? Come on. It is known as a unity feedback system, guys. Then it is called as a unity feedback system, guys. In that case, if it is a unity feedback system, then only then this is referred to as some constant value known as k. Known as k. Listen to me very carefully. Terms and conditions are applied, guys. For that, h of s should be compulsory 1. H of s should be compulsory 1. Then only I'm going to consider this whole, whatever I have highlighted, as a k value. Please remember, the step input is also called as a position input. Step input is also called as a position input. So I would refer to this as Kp. Kp, which is popularly known as a positional error coefficient. It is known as a positional error coefficient, guys. Okay. Then I'm going to write my ESS, which is equal to 1 upon 1 plus Kp. ESS equal to 1 upon 1 plus Kp. Now let me declare, guys. Let me declare, guys. This formula which I have written, ESS is equal to 1 upon 1 plus Kp. This is applicable only and only if h of s equal to 1. That is nothing but a unity feedback system. Let me tell you very clearly, Kp cannot be defined for a non-unity feedback system, guys. Kp cannot be defined for non-unity feedback system. Kp, Kv, Ka, which will come later, are going to define only for, those systems which are unity feedback system, guys, which are unity feedback system. So please make a note of it. Okay, ESS is equal to 1 upon 1 plus Kp. Okay, and let me tell you, if h of s is not equal to 1, guys, if h of s equal to some non-unity value, you can still go for this formula. You can calculate ESS. Okay, you can calculate ESS, but you cannot calculate ESS in terms of Kp. You cannot calculate ESS in terms of Kp. In terms of Kp, it is possible to calculate only and only if it is a unity feedback system, guys. Okay. So what is Kp? Come on. Kp is limit s tends to 0, guys, g of s into h of s. And obviously, when h of s value equal to 1, you can avoid writing h of s. You can just write limit s tends to 0, g of s. I'm sure you understood how to get Kp value. How to get Kp value, guys. Okay. So I'm going for the next input, guys. I'm going for the next input called as the unit ramp input. Okay. So for unit ramp input, I'm sure you remember, guys, R of s value equal to 1 upon s. Yes or no? R of s value equal to 1 upon s, guys. Yes or no? R of s is equal to 1 upon s. So just hold on, guys. We already had a formula. ES is equal to limit s tends to 0. S into R of s, guys, whole divided by 1 plus g of s h of s. Yes or no? Hey, let me substitute. Limit s tends to 0, guys. S into R of s is what? This time it is 1 upon s square. I'm so sorry for that. It is 1 upon s square, guys. So let me substitute 1 upon s square whole divided by 1 plus g of s into h of s, guys. Yes or no? Here, I can cancel s with this square. Yes or no? What is remaining? Let me write the remaining thing again. I can write this equal to limit s tends to 0. Okay. 1 upon, see, this s will get multiplied with 1 also and with this also. So it will become s plus s into g of s into h of s. So far, this is ESS formula that I have derived, guys. Yes or no? Now my duty, guys, to substitute s equal to 0 wherever possible. Wherever possible, I'll substitute s equal to 0. So, guys, you can substitute s equal to 0 in first term, but you cannot substitute s equal to 0 in second term because g of s, h of s is not known to us, guys. G of s, h of s is not known to us. So, you cannot substitute s equal to 0 in second term. So, what is remaining? The remaining thing I'll write ESS equal to, I can write 1 upon, okay, this s will become 0, so it is as good as not there. Limit s tends to 0, guys, s into g of s, h of s. So this is the final formula, guys. This is the final formula you have. ESS equal to 1 upon limit s tends to 0, s into g of s, h of s. I hope you understood this, guys. I hope you understood this, guys. And let me tell you, this is applicable. This formula is applicable for unity feedback system also and for non-unity feedback system also. Okay. But in case it is unity feedback system, this whole denominator, guys, this whole denominator is again considered as some constant value or a error coefficient. And let me tell you, the name, alternative name for ramp input is a velocity input. Therefore, since it is a velocity input, guys, I can refer this K as KV. I can refer this KV as what? A velocity error coefficient. Now I can write my ESS equal to what? Come on, guys. I can write it equal to 1 upon KV. 1 upon KV. Again, this formula is applicable. That is ESS in terms of KV, guys. You can write only and only if for unity feedback system. Otherwise, you can't write. Otherwise, you can't write. So only for unity feedback system, I can declare my KV as what? Limits s tends to 0, guys. S into g of s, h of s. So again, what I have written over here and whatever I'm highlighting with red color is applicable only if and only if h of s equal to 1. And I'm sure you understand the meaning of h of s equal to 1. This h of s equal to 1 means it is a unity feedback system. Please never ever forget this. Please never ever forget this. Okay. I'll take a short revision also at the end. So don't worry, guys. I'm sure you are writing or you are having some notebook with you when you are watching these videos. Okay. Let me know, guys, if you have understood this. Let me know in both the cases. See, every time KV will not become 0. Ready? So please don't do that. Okay. It depends upon the G of s, h of s factor. It depends upon the G of s, h of s factor. Imagine ready. G of s, h of s value is 1 upon s. Assume G of s, h of s value is 1 upon s. So can't you see at this time SS will get cancelled, guys. SS will get cancelled and KV will become 1. So you cannot comment that KV equal to 0. Don't blindly substitute s equal to 0 because G of s, h of s is not known to me. I hope you understand my point. Yes. So guys, I'm going ahead. So for third input, I'm going. Known as unit parabolic input. A unit parabolic input is also known as an acceleration input. Never forget that. So in case of acceleration input, R of s is known as 1 upon s cube. I'm sure you know that. Yes. Yes, of course. Not in the next class. I'm planning to take the problem in this class only. Okay. So look at this. Okay. Unit parabolic input I have taken. R of s is equal to 1 upon s cube. And let me repeat my formula. ESS was limit s tends to 0, guys. S into R of s upon 1 plus G of s H of s. This kind of ESS we have, right? For which R of s is equal to what? 1 upon s cube. Yes or no? Let me substitute, guys. Let me substitute. ESS equal to limit s tends to 0. S into R of s is 1 upon s cube, guys. Whole divided by 1 plus G of s into H of s. Yes or no? So here, can you see there is a cancellation? There is a cancellation. This s will get cancelled and it will become s square. Isn't it? Now this s square will go down and will get multiplied with both the terms. Am I right? Effectively, what ESS we have? See, ESS that we have, guys, is 1 upon s square plus s square into G of s H of s, where I would say for both the term, limit s is tending to 0, guys. Limit s is tending to 0. But try to understand my point. My point is, you can substitute s equal to 0 in first term, but you cannot substitute in second term, guys. Reason, G of s H of s is still a question mark for us. Yes or no? Therefore, you are not going to substitute s value equal to 0 in second term, but in first term you can substitute. So when you substitute s value equal to 0, 0 square remains 0, guys. So what is remaining? Simply ESS is equal to 1 upon limit s tends to 0, guys, s square into what? G of s H of s, guys. This is what is remaining, guys. This is what is remaining. Now let me tell you guys. 1 upon limit x tends to 0, s square into G of s H of s. This formula is applicable, guys, for unity as well as non-unity feedback system. I repeat, it is for unity as well as non-unity feedback system. But if and only if H of s equal to 1, that is nothing but a unity feedback system, guys, then I'm going to highlight the lower term. And let me tell you, this is known as Ka, guys. That is acceleration error coefficient. Acceleration error coefficient, guys. So I can write my ESS is equal to 1 upon Ka. I can write my ESS equal to 1 upon Ka, guys. I hope you understood that. ESS is equal to 1 upon Ka. Okay. And again, this Ka is what? Ka is limit s tends to 0, s square into G of s H of s, guys. Okay. So I'm sure you understood this. Okay. I'm sure you understood this, guys. Okay. Okay. Very good. Very good. Velocity to acceleration. Okay. Great. Okay. So I'm sure you understood this, guys. Okay. Is there any problem so far? So as I said, that at the end, I'll take a short revision. So time to take a short revision and then we'll start with the numerical. Okay, great. Thank you. So time has come to take a short revision. Guys, be quick. Be quick. What we have seen so far, guys. What we have seen so far, guys. See, first thing that we have seen, guys, steady state error, we always get at the end. At the end. So ESS is always, actually, it is function of time. Error is a function of time. But when time is approaching to infinity, this is the first thing that we have seen, guys. Am I right? Second thing we have seen, expression for E of S, which is R of S whole divided by 1 plus G of S H of S. Third, we have seen ESS is always limit s tends to 0, s into R of s whole divided by 1 plus G of s H of s. So from this we concluded that ESS is a function of input and ESS is also a function of system parameters, that is nothing but G of s H of s, guys. Right. And one more thing I told you, this ESS formula is applicable for unity as well as non-unity feedback system. So I'm just taking a short revision, guys. I'm just taking a short revision. Okay. Next, Since R of S, okay, R of S stands for input, and if input changes, ESS is going to change. So in case of unit step input, guys, which is also known as a position input, we have seen ESS comes out to be limits S tends to 0, 1 upon Kp, 1 upon 1 plus Kp. 1 upon 1 plus Kp. Provided, now this ESS is applicable only if H of S should be equal to 1, guys. H of S should be equal to 1. Compulsory. No option, okay? Okay, great. So next, guys, when it is a unit ramp, guys, okay, that is nothing but a velocity input. ESS is always limit S tends to 0, okay, 1 upon kV. Again, at the end, we have seen for unit parabolic, guys, unit parabolic input, also known as acceleration input, guys, ESS is always limit S tends to 0, 1 upon Ka. Okay, all this discussion is valid only and only for H of S equal to 1. Please understand my point. Next, Kp value, Kv value, and Ka value. Kp value, okay, what was that? It is limit S tends to 0, guys. G of S, H of S. H of S must be 1. Only then Kp is valid, guys. Kv, limit S tends to 0. S into G of S, H of S. That's it. This is called as Kv. And at the end, we have seen Ka also, which is limit S tends to 0, guys. S square into G of S, H of S. Can you see? Okay. Here there is no S. Here there is S raised to 1. Here it is S square. And otherwise the formulas are same, guys. Otherwise the formulas are same. Yes, what you said is correct. Every time S is going to get multiplied, guys. Every time S is going to get multiplied. So with this short revision, as I promised, that I'm going to start with the numerical. Okay. So be ready for numerical. I'm sure you have written all these formulas with you. And you are ready for solving the problem. Let me put a very first problem in front of you, guys. Okay, other than ready, is there anybody who is also understanding, guys? Okay, please do answer if you're understanding this, guys. So I guess we should go to the problem now. Yes. So look at this problem, guys. The problem is in front of you. I want you people to solve this. The unity feedback system, as shown in the figure. Okay, whatever the system is given, and you have 4 options, guys. You have to tell me the correct option. Go ahead, guys. Now you have everything with you. Okay. You already have a formulas with you. I would like to know, you have zero steady state error, or zero steady state velocity error, k by 10 steady state position error, or k by 10 steady state velocity error. Come on, guys. I'm sure you remember when it is position. Okay, the input is unit step. When they say velocity, guys, the input is a unit ramp. As you can see in this problem, there is no acceleration word, guys. So you don't have to worry for third input. You have to worry only for 2 inputs, a position input and a velocity input. Is there anybody who is ready with the answer? Is there anybody who is ready with the answer? It's a very simple question I have asked, guys. The problem is in front of you. You have to answer. Okay. Only Reddy is solving. What about other guys? Are you solving? Okay, Prasanna has come up with the answer. C, this is k by 10. Okay, is there anybody who wants to differ from Prasanna? He got steady state position error. as k by 10. Is there anybody with another option? Or shall we consider C as the correct option? Come on, guys. Take a minute. No problem. Take a minute. One more minute you take. Okay, even okay. Everybody's getting C. Oh, that's great. That's great. I don't know what you did, but you got option C. Very good. Let me see if it is correct. Hey, there are 3 people with answer only. What about other people? I can see 10 to 15 people are there who is watching this. What they are doing? Come on, guys. Come up with the answer. Okay. So, people, please pay attention. In all the options, they are asking you about common thing, guys. Error. They are asking you about error, guys. Okay. So, let me take case number 1. Position input. Position input, guys. I want to know from you guys, can I write ESS for position input as 1 upon 1 plus KP in this case? Tell me, is this formula what I've written, ESS is equal to 1 upon 1 plus KP, guys, is it valid? In this case, is it valid? I told you in which case 1 upon 1 plus KP formula is valid, guys. Come on, guys. I would like to know from you guys. Is this valid what I've written, guys? 1 upon 1 plus KP. Of course, for unity feedback system, guys, for unity feedback. Can't you see, guys, there is nothing over here. It means it is h of s equal to 1, guys. It indicates it is a unity feedback system, guys. It is called as a unity feedback system. And therefore, I can write this formula. I can write this formula. Am I right? Yes. So let me write, guys. ESS equal to 1 upon 1 plus, come on, if you remember KP formula, guys, limit s tends to 0. I'm just writing GH, okay? I'm just lazy to write G of S, H of S, guys, okay? So ESS equal to 1 upon 1 plus limit S tends to 0, guys. Hey, come on, if you remember, this is G of S, guys. And H of S value equal to 1. So I have to write what? K upon S into S plus 10. I hope you understand that. K upon S into S plus 10, guys. So what is going to happen? Just substitute S equal to 0. Just substitute S equal to 0. What is going to happen? Is there anybody who can tell me what will happen when S equal to 0, guys? Common sense. This denominator will become 0, guys. Anything divided by 0, guys. Anything divided by 0, guys. Come on. Anything divided by 0, infinity. Anything divided by 0, infinity. So I can say it is equal to 1 upon 1 plus infinity, guys. So it is equal to 1 upon infinity, guys. It indicates it equal to 0, guys. It is equal to 0. It is equal to 0. Finally, I got ESS equal to 0. What is meant by ESS, guys? What is meant by ESS, guys? Come on, it is called as a steady state error. It is known as a steady state error. Can I say it is nothing but steady state error, guys? It is nothing but steady state error, guys. Okay, my speaking speed is high. Oh, okay. So can I say that steady state error is 0 when the input is unit step? When the input is unit step. I hope this speed is okay with you, Madan. Steady state error equal to 0 when input is unit step. Okay, thank you, Madan. So I can say steady state error. Okay, that is nothing but I can go with option A, guys. I can go with option A because the steady state error means what? Steady error. When what input is given? Come on, position input is given. I'm sure the reason why you got option C, because looking at steady state error, you must have gone for steady state error coefficient. Try to understand. They have asked you error and not coefficient. Okay, they have asked you the error and not coefficient, guys, and that's the reason why option number A is correct. That is nothing but 0 steady state error when input is a position input. I hope you got that. I hope you got that. See, these are like gate questions. This kind of questions you get in gate exam. Okay, they try to confuse you guys because We already have seen na, this term as steady state error coefficient. Okay. Ultimately, you have got a habit. Ultimately, you have got a habit to say coefficient. Okay. So let me tell you, they haven't asked you steady state error coefficient. They have asked you only error, guys. Okay. Prasanna, Gopi, have you understood where you made a mistake? I hope you understood where you made a mistake. Okay. See, guys, you know what? I'll go for a velocity input now. I'll go for a velocity input also. Okay. Let me see for velocity input. So I'll rub this and I'll take velocity input. Okay. I'll take velocity input now. So I'll go for second case, guys. Look at this carefully. I'm going for a second input. That is nothing but velocity input. Okay. Velocity input, you know, ESS is equal to 1 upon kV, guys. ESS is 1 upon kV. So I can also write ESS equal to 1 upon limit s tends to 0, guys, S into GH. S into GH. So now I can write ESS equal to 1 upon limit s tends to 0, S into, hey, what is GH value? GH value is K upon S into S plus 10. Yes or no? Here SS gets cancelled, guys. Here SS gets cancelled. Now you just substitute S value equal to 0. So when you do that, what ESS you get? See carefully. You get 1 upon, okay, 1 upon K upon 10. So ultimately, ESS comes out to be 10 by K. ESS is equal to what? 10 by K. Yes or no? I hope you understood that. This is called as what? This is called as a steady state. Steady state. Velocity error. This is called as a steady state velocity error, which is 10 by K. I'm sure you understood this, guys. I'm sure you must have understood this, guys. Okay, let me know, guys, if you have some doubts in this problem. Let me know if you have some doubts. Else, I'm moving for the next problem. What about other people? Madan, have you lost? Are you understanding this? Yeah, no problem. Madan? Gopi? Prasanna? Where are you guys? Have you all understood that? I would like to know from you. Else, how can I switch to the next problem then? Great, Gopi, great. So, since Gopi have understood, I'm going ahead. Okay, I'm going ahead, guys. Okay, I'm going ahead with the next question. Okay, look at this. The question is in front of you guys. Yeah, Madan, please tell me. Uh, what you have not understood there, please let me know. Okay, very good, Prasanna. Okay, hey, otherwise, guys, please start with the next problem, guys. Okay, read the problem. The block diagram shown in the figure gives a unity feedback closed loop system. Yes, we can see. If nothing is there, means h of s equal to 1, guys. What they are asking you, they're asking you steady state error in response to system to unit step. Come on, a very straightforward question. I want you people not to let me down and answer my question. Come on, guys, go ahead. Start doing this. Very simple. Very, very simple. You know, when unit step input is applied, what is a steady state error formula, guys? Don't let me down. I'm sure you are going to do this. Very simple question, guys. Very, very simple question. Is there anybody with the answer? Come on, guys. It shouldn't take so much time. Is there anybody with the answer? Come on, guys. It's a very straightforward question. It's a straightforward question, I would say. Okay, you got option A. Is there anybody with the another option? Is there anybody who would like to differ with Reddy? Okay, let's see. So for steady state error, when it is a unity feedback system, I know that ESS is simply 1 upon 1 plus KP, guys. I can do that. Yes or no? This is applicable only when it is a, okay. Oh, now you are changing the answer. Okay, option B. Okay, B pakka you are saying. Let me see. ESS is equal to this, or ESS is equal to 1 upon 1 plus, limit S tends to 0, guys, multiplied by GH, multiplied by GH. But then what is G, guys? Hey, come on. Two blocks are connected in series. Two blocks are connected in series. Gets multiplied. Yes or no? So G1, G2 will become G1, G2 now. So ultimately, the product of these two blocks will become what? Numerator multiplication, guys. 45. Now 15 3s are 45. Divided by, you get two brackets, guys. S plus 1 multiplied by S plus 15. Yes or no? This is what is remaining, guys. Okay, so let me substitute, guys. Let me substitute over here. This 45 whole divided by S plus 1 into S plus 15. Yes or no? Now, simply wherever there is S, guys, substitute equal to 0. Okay, substitute equal to 0. So when you substitute equal to 0, guys, what you will get over here? 1. What you will get it over here? 15. Come on, 15 into 1 is what? 15. 45 by 15 is 3. 3 plus 1 is 4. ESS has become 1 by 4. You have 1 by 4. But look at this. All of them are in percentage. So when you have to have percentage ESS, multiply with 100. Multiply with 100. Come on, guys. What is 1 by 4? Is there anybody? Is there anybody who is going to tell me the final answer now? 1 by 4. Come on, 1 by 4 is 0.25 multiplied by 100. So it is 25%, guys. So it is option A. Option A is the correct option. Very good. Option A is the correct option. So I'm sure you understood those numericals. Okay. In the next lecture, we will take more numerical. Okay, we will take more numerical, and we will see, ESS dependency. We have seen only in terms of input only. We have not seen ESS dependency on G of S, H of S. So in the next lecture, we will still go for the next part of this steady state part, and we will see ESS dependency on G of S, H of S also. So thank you so much for watching this, guys. I'm sure you enjoyed this lecture. You understood each and everything, and this is what I really want, guys. Okay, so stay tuned, guys. Okay, keep subscribing, keep hitting the like button. Okay, and stay tuned, and you will see a new concepts, guys. We would be going ahead in the future lectures. We will be taking Bode plot, inverse Bode plot. We will see root locus, Nyquist plot, polar plot. Everything we are going to cover, guys. Everything we are going to cover, guys. Okay. Okay. See, no problem. It doesn't matter whether it is unit step or unit ramp or a unit parabolic. Okay. You have to only worry about the formula. Okay. And yes, for signal flow graph we have already done. You can watch previous videos which are available there. So signal flow graph lecture is there. You can see that lecture also. Yes, you are most welcome, Madan. You are most welcome, guys. Okay. Thank you so much for watching this. Myself, Abhishek Barve, I sign off. Thank you so much, guys. Good night. Take care. Bye-bye. And see you in the next lecture, guys. Take care.